All right, in this lecture, we're going to go over what is a property, what is a state, and what is a process. In order to describe the systems that we defined previously and predict their behavior, we require knowledge of its properties and how these properties are related. So a property is a macroscopic characteristic of a system to which a value can be given without knowledge of the previous behavior of the system. Some examples of properties include mass, volume, energy, pressure, temperature. Properties are independent of the process, which means they don't depend on how you got from one state to another. And by state, I mean the state refers to the condition of a system as described by its properties. You go from one state to another by undergoing a process, and a process is a transformation from one state to another. So if a system exhibits the same values in its properties at two different times, it's at the same state at these times, and the system is said to be at steady state if none of its properties change with time. Importantly, I want to stress that a quantity is a property if and only if its change in value between two states is independent of the process. If something depends on the process, it is not a property. So there's some different kinds of processes. But first, I'm going to show you a process. Here we have some gas in a piston or liquid. And it's got some initial state. So it says state 1, it says a pressure, it has a volume, it has a temperature, and it has a position. If this piston, for example, moves over to here, now we have state 2, which has a new position of the piston, a new volume, a new pressure, and a new temperature. So I'm going to make a graph of pressure versus volume to show you some different processes. A horizontal straight line is constant pressure, which is called isobaric. A vertical straight line is constant volume, or isometric. And on this case, a curved line like this is isothermal. which is constant temperature. We have something, a cycle, which is what I just drew, is a series of processes that begin and end at the same state. So properties can either be extensive or intensive, and a property is extensive if its value for the overall system is the sum of its values for the parts into which we can divide the system. So for example, some examples, so extensive properties depend on the size of the system. And they change with time only. So for example, say I had a container and it has oil on top and water on the bottom. I have a volume of oil, I have a mass of oil, I have some energy, I have volume of water, I have mass of water, and that water has some energy. So some examples of extensive properties are mass, volume, and energy, because the mass of my system is the mass of the oil plus the mass of the water. The volume of the system is the volume of the water plus the volume of the oil. And the energy of the system is the energy of the water plus the energy of the oil. On the other hand, intensive properties are not additive. In the same way that extensive properties are. They are independent of system size. They can vary from place to place within the system. So they are functions of position and time. Some examples include pressure, temperature, density, and specific volume. All right. Then add examples previously in the notes. So the last thing we're going to go over in this lecture is the definition of equilibrium. So classical thermodynamics places the primary emphasis on equilibrium states. So we're changing from one equilibrium state to another equilibrium state. So the concept of what equilibrium is fundamental to our study of thermodynamics. So in mechanics, if you remember, equilibrium means a condition of balance is maintained, usually by opposing forces. So your sum of your forces is equal to 0. The sum of your moments is equal to 0. In thermodynamics, we're going to take this concept much further, because it's not only going to include a balance of forces, which it does, but it's also going to include a balance of other influences. As we go through the course, we will slowly define more and more of these influences. So several types of equilibrium exist. These include thermodynamic equilibrium, complete equilibrium. So to fulfill equilibrium, we must fulfill complete equilibrium, so we must have mechanical equilibrium, phase equilibrium, thermal equilibrium, chemical equilibrium. So to check for equilibrium, what do we do? Well, first we isolate our system from its surroundings, and then we watch for changes in its properties. If there are no changes, we can conclude that the system was in equilibrium the moment that it was isolated, at which the system is said to be at an equilibrium state. When a system is isolated, it doesn't interact with its surroundings. However, your state can change due to spontaneous events occurring internal to the system and its intensive properties, such as temperature and pressure, which are going to tend towards uniform values. So when all such changes stop, the system is said to be in equilibrium. And one last final note is that at equilibrium, both temperature and pressure are uniform throughout the system. In the next lecture, we're going to go over units, and then we're going to go over units and specific volume.